Let's do another, maybe a trickier. Another little setup to solve the triangle. 3 pieces of information. An A, a B, and a C. Shit, that's telling you straight up. You got a lot of cosines when you get all the letters in there. It's got to be a lot of cosines. So here's the same triangle. I didn't change it from the last slide, so just this is the same one. So this is not to scale. Like let's make sure we know this. Like, this is not to scale. Just kind of making some stuff up, little make-em-ups. But it's to get us an idea as to where things are. And we're like 7, B is 4, and then C would be over there. So then our angle is C's here. So let's write in the rest. What do we got to find? A, B. So this is side C. This needs to be angle A, and this needs to be angle B. Ah, cool. Cool. We only have one idea. We got side, angle, side. That's telling you we're going to go get C. Therefore, we'll use the formula right there. Let's go. Let's set it up. So we're going to say that C squared is equal to, let's set it up in this way. So A squared is our 7 squared plus our 4 squared minus our 2 times 7 times 4 times cosine of the angle that's in between, that 20 degrees. Now C is going to be equal to the square root of all of this, so possibly cleaning it up, maybe just a teeny bit. I end up with, I think that's 65 minus 56 of cosine of 20 degrees. Maybe use your calculator at that point, but you got to make sure you get it. So I'm hitting my buttons and getting the calculator and making sure that I don't do something silly and have the fat fingers issue. I'm telling you, it's easy. It's very easy when it matters. So 3.52. 3.52 looks to be about a solid answer for that side. And now we have a ratio that we can set up. So let's look at our, what do we got? We got this ratio. Cool, so we can now use the law of sines. We can now use the law of sines by using this ratio, sine of 20 degrees over 3.52. We have that ratio that allows us to be like, dude, we can go get A. We can go get B. We're ready to go. We got the ratio. We're ready. Now, I'm going to do this wrong. All right, this is wrong. What I'm about to do below. I'm going to go after A. I'm going to set this up and say sine of 20 degrees is equal to 3.52, which is equal to, and now I'm going to do this all in red to show you, like, no, this is not right. This is not right. And saying sine of, and if I go after angle A, I'm not going to get the right answer. That's actually not true. We don't know if it's not true, but it goes back to this logic. I mean, at the beginning, you wouldn't know. It goes back to this logic. One angle could be larger than 90 degrees. Can't you have an angle that looks like this? Like this angle here. That's big. That's a big angle. It's like a flying saucer. So one of them could be larger than 90 degrees, and sine inverse wouldn't understand it, and it would just give you the reference angle. But only one of those angles could possibly be, like, 20 degrees gets you 3.52. Well, 20 is probably going to be one of the smaller angles. It's not even probably, it is the smallest angle, because the smallest angle is opposite the smallest side. And 3.52 is smaller than 4, and 4 is smaller than 7. So the largest angle that we have is it's got to be A. The largest angle is A. So by going after the largest angle with the law of sines, that's a terrible idea. We're going to end up getting the reference angle of the answer we want. So now I'm going to run it through quite quickly and just say that A would end up equaling, and that's sine inverse of 7 times sine of 20 all over 3.52. Oops, said I'm doing this in red because it's freaking wrong. And this would say that A is equal to, what is this? I'll have to punch it in. 42.9 degrees. Now let me show you something. Let me show you how ridiculous this is. All right. Cool. 42.9 degrees. Now remember, all of this is wrong. So I go into here and I go, all right, this one's 42.9 degrees. And if that's 42.9 degrees, come on, let's do it. 180 minus 20 minus 42.9 degrees. We're going to say that this has got to be 117 degrees. So opposite 42 degrees is 7. But opposite 117 is only 4. If you believe that, I got property. I'd love to show you. I can sell you on it. Of course that can't be right. That's just not possible. So let's back out of this. And that's some nonsense. But I'll bet you that number 42.9 might come back into play. But the way we're going to fight this, don't go after the largest angle. Go after the smallest angle with the law of sines. S with S. So let's do it the right way. So let's stop looking at all this down here. Stop looking at all of this. 42.9. Remember that number if you could. So let's go after this one. Let's go get B. So we'll go get sine of B. Over 4, we multiply the 4 over. Get 4 times sine of 20 over 3.52 is equal to sine of, and there's that B. We're going to hit both sides of this thing with an inverse, knowing that this angle B is less than 90 degrees. And that's why B is actually going to pop up. Remember when it was this is inside of this thing, is inside of whatever, and it equals what's inside of it as long as it's within the domain of the function? I don't know if you do, but so B is approximately equal to 22.9 degrees. And we can replace. So 22.9 degrees. Oh, an angle a little bit bigger than 20 gave you something a little bit bigger than 3.52 with that sine. That makes a little bit more sense. And now if we do the full subtraction, we're like 180 minus 22.9 minus that 20 that we already had. That's going to give you 137.1 degrees. And we go this one, this one here is 137.1 degrees. And now what we have is we have the largest angle opposite the largest side. We have the smallest angle opposite the smallest side. And we have the middle angle opposite the middle side. Now what I'm curious to know is what's the reference angle of 137.1 degrees like we just found right here? What's 180 minus that? What's 180 minus 137.1 degrees? Is that equal to, is this? No, it's not equal to that reference angle we found down here when we did it wrong, was it? It is. We would have found the reference angle because sine inverse does not understand angles larger than 90 degrees. To avoid this, you always go for the smallest angle when using the law of sines if you have a choice. You do that, there's no issue. You don't do that, guaranteed issues. Cool. See you in the next.